Okay, hi guys. So today would be the first day of Unit 8, and it's on binomial geometric probability. So what is that? You've probably never heard of that. So first we're just going to write out some definitions and stuff. So today we're going to be talking about a binomial random variable. And a binomial random variable is a discrete random variable. That counts the number of successes in a fixed number of trials. So, for example, you could find out the probability that, out of the next 5 games, that certain team's going to win 3 of them or something like that. But you would have to know the probability of one win to do it. So the number of trials would be how many games or how many days you're looking at, and the number of successes could be wins or losses or whatever. Okay, so here's the properties of these binomial probability distributions. Okay, first of all, there are n repeated trials, and n could be any number of trials, but you need to know that number because there's a formula that will have n in it. All the trials are identical and independent. Each trial only has 2 possible outcomes. That's why it's binomial: success and failure. The probability of success we call P, and that's in one trial. And you'll have to know that to calculate this. So the probability of success in a given trial is P. So the probability of failure is 1 minus P. So of course those have to add up to 1. So we use these letters N and P and another variable K in this formula that you are given on the AP. And I'll explain how to use it and what all the letters mean. So X will be the number of successes in N trials. Okay, so it could be 0, 1, 2, all the way up to N. So if there's 8 trials, you could have 0 through 8 successes. The probability of K successes, however many that is, in N trials. This is a formula that's given on the AP. And I'll explain to you what this NK in parentheses means. N over K, it looks like. P to the K, 1 minus P to the N minus K. Okay, this looks like a very weird, complicated formula, but you'll see how to use it in a minute, and it is given, so you don't have to memorize it. All right, so let me show you how to use it. So a binomial random variable X equals B. You know how with normal distribution we put a big N? For this we put a B, and then with the normal distribution we put the mean and then the standard deviation. For this we're going to put N and then P, the number of trials and the probability of success. Those are the 2 numbers you would need. Okay, so that the formula that I boxed has that n over k, like in parentheses. That's actually what we call a combination. So NCR is what it looks like on the calculator, but for some reason they give it as NK on the AP. But it's the same thing as NCR. So I don't know if you've ever really seen NCR before, but it has to do with combinations. So NCR is like if you have 4 things and you're taking 2 at a time, how many combinations are there? That's what it really means. To calculate it, you'd have to know N and you'd have to know K or R. So N would be the number of trials and K would be the number of successes. You'd have to know those 2 numbers. And then, like, for example, I'll do it with 2 numbers, like 4C2. To get it in the calculator, you're going to press Math. You're going to arrow over to Probability, P-R-O-B. And then number 3 on that menu says NCR. And then you would put in like the 4 and the 2, and it will calculate it for you. And 4C2, this is how it's calculated. It's 4 times 3 over 2 times 1, but you don't even have to know that. You can just put it in your calculator, and it's going to give you 6. So to put it in your calculator, you would go to Math, Probability, number 3 NCR, then before the C you put the 4, after the C you would put the 2. So 4C2 is the same as 4-2, like this in parentheses. So 4C2 is how it looks in the calculator, but 4-2 in parentheses is how it looks like in the formula. So those are the same thing. And you get it by doing Math Probability 3 on your calculator. All right, so I'll go over that again when we have to use it. So now we're going to create a probability distribution for binomial random variable. Still using RV to mean random variable. So x equals b for binomial, and then if I give you a 4 and a 0.3, the 4 is the number of trials, that's the n, and the 0.3 is the probability of success, that's p. So that formula that is given, nk, p to the k, times 1 minus p to the n minus k, that's how you find out the probability of each of, like if you have 4 things taken 3 at a time, or 4-2, or 4-1, or 4-0, you use that formula for all of them. So I'll show you with a table. So if x, since n is 4, that's the number of trials, the successes could either be 0, 1, 2, 3, or 4. So the probability of x we have to get from that formula. So I'm going to show you each one down here. So the probability of x equaling 0, you would do 4-0, which I'll show you how to do on the calculator. Then you would plug in p, which is 0.3, to the k power. Well, k really is the x, so that's 0. And then if the probability of success is 0.3, then the probability of failure is 0.7. You do 1 minus. And that's to the 4th power because it's n minus k. So these 2 exponents will always add up to n. All right, and to calculate this, in your calculator, the 4-0, you put in your calculator Math, PRB, or prob, I think it says, PROB, number 3. And it's going to give you that little NCR. You're going to do 4C0. So if you put that in your calculator, you'll see it's 1. Anything C0 is 1. Just like anything to the 0 power is 1. So 4C0 is 1. So this is going to be a 1. Anything to the 0 is also 1. And then you can just do the 0.7 to the 4th power. And that's 0.2401. So the probability of x being 0 is 0.2401. So that goes in our table. Okay, to get the probability at 1, you're going to do the same formula. But now it's 4-1, which we'll get from the calculator. The 0.3 is now to the 1st power, and the 0.7 is going to be to the 3rd power. Those always add up to 1. Those 0.3 and 0.7 add up to 1. The exponents always add up to n. So they're 1 and 3. So to put this in your calculator, 4C1 is 4. You can use that math probability. 0.3 to the first is 0.3. 0.7 to the third is 0.343. Multiply all that, you get 0.4116. So that's the probability at 1. And there is a way to get this entire table from the calculator, and I'm going to show you that too. But you have to know how to use the formula. So at x equals 2, it would be 4, 2, 0.3 to the second, 0.7 also to the second, because those exponents will always add up to n. Put that in your calculator. That 4, 2 comes out to 6. This is 0.09. This is 0.49. So that comes out to, when you multiply at 0.2646. Okay, we're going to do the other two. Probability that x is 3 is going to be 4, 3. 0.3 to the third. 0.7 now to the first. Those add up to n. 4C3 is actually equal to 4. 0.3 to the third is 0.027. And that's 0.7. Multiply that. And that's 0.0756. So that's the probability here. And then the last one is when x, which is really the same as k, is 4. Whoops. And that's going to be 4C4, or 4 over 4 like that. 0.3 to the fourth power, 0.7 to the 0. 4C4 is 1. This is 0.0081. This is also 1. So that comes out to 0.0081. So that's our probability distribution. Now, instead of doing all that, you can get all of those numbers from the calculator. On the menu that we do normal CDF, there's also something called binomial PDF. And binomial PDF is going to give you each one of those separately. And you don't have to do them all separately. You can do it all as a list. So I'll show you how to do that. Now, just write down the calculator steps and make sure you try them yourself and make sure they work. So on the calculator, for probability of x equals k, we use binom PDF to get each one. So in your table, you're going to do stat edit. And in L1, I'm going to put the ends 0 through 4. And then instead of doing all those calculations, the calculator is going to do them all for us. So go to stat edit, put in L1, 0, 1, 2, 3, 4. Okay, now we want to tell it to do all of those binomial PDFs into L2. So here's how you do it. After you have it in L1, press second vars, and you'll see that whole distribution menu. You have to scroll quite far down to find A. So I'll write this down. It's second vars, A. And it'll say binom PDF, and then it'll have an open parenthesis. So you're going to hit that, press enter. Then it's going to say trials. Trials is N, so we're going to put 4. Then it's going to say P. P is the probability of success. We were given that at the beginning. It was 0.3. So you're going to put that in there. Then it says X value. Whoops. Now we want all the X values. So we're going to put there L1. And it's going to use every X value from L1. Then you're going to hit paste. But then you have to tell it to store it in L2. So then you're going to hit store. And then you're going to hit L2. And then it should put all of those decimals that we just found into L2. So just to make sure we got it, stat edit L1, 0 through 4. Get out of there, go on the regular blank screen, press second vars, scroll to A, which says binom PDF. Trials is 4, probability is 0.3. The X value is all of list 1, so L1. Paste, but don't hit paste again. Once you hit paste once, it's going to say binom PDF 4, 3, L1. Then you're going to hit store, L2, enter, and then it's going to give you these values like this. It's actually listing them But now they're in L2. If you go to stat edit, they're in L2, and they're the same ones we just found. Now, if you forget how to do that, you could just find each one separately. You could just find 0's value, then 1, then 2 by doing binom PDF for each one. But this will do all of them when you're telling it that your X value is list 1. Okay, that's all we're going to do today on this. We'll do more next time, but let me give you the homework. It's in the textbook. So it's page 441, exercise 8.1. That's just, you're going to decide if things are one of these distributions or not. So use the properties I told you to see if you think that it's a binomial distribution. That's for exercise 8.1. And then on page 445, you're going to actually do some calculations. It's 8.3 A through C. Okay, so tomorrow, hopefully, Google will be working normal. We'll have a normal meet. All right, have a good day.